So here we're going to start with Linux fundamentals. The Linux fundamentals part 1. Task 1 introduction. Welcome to the first part of the Linux fundamentals from series. You're most likely using a Windows or Mac machine. Both are different in visual design and how they operate. Just like Windows, iOS, and Mac OS, Linux is just another operating system and one of the most popular in the world, powering smart cars, Android devices, supercomputers, home appliances, enterprise servers, and more. We'll be covering some of the history behind Linux and then eventually starting your journey of being a Linux wizard. This room will have you running your very first commands in an interactive Linux machine in your browser, teaching you some essential commands used to interact with the file system, that demonstrate how you can search for files and introduce shell operators. Okay, so this task introduces you to the Linux fundamentals learning path on Tryhackme. And the key points that I should understand is that Linux is an operating system just like Windows or Mac. It is one of the most widely used systems in the world. It runs on devices such as Android phones, servers used by companies, supercomputers, smart appliances, many other systems. In this learning room, I will start learning how to use Linux through my browser. What I will learn next in this series is how to run basic Linux commands, how to move around and manage files and folders in the Linux system, how to search for files and use shell operators. Um, those are special symbols that modify how commands work. So this task is just an introduction, letting me know what to expect. Okay. So in the first task, we are told that Linux is a very important operating system used all over the world. In this room, we will begin learning how to use Linux by practicing commands, navigating files and folders, and searching for information inside the system. Right. So for this, let's get started. We don't need to answer any questions. Task 2, a bit of background on Linux. Where is Linux used? It's fair to say that Linux is a lot more intimidating to approach than operating systems such as Windows. Both variants have their own advantage and disadvantages. For example, Linux is considerably much more lightweight, and you'd be surprised to know that there is a good chance you've used Linux in some form or another every day. Linux powers things such as websites that you visit, car entertainment or control panels, points of sale systems such as checkout tills and registers in shops, critical infrastructure such as traffic light controllers or industrial sensors. Okay. Flavors of Linux. Linux is actually an umbrella term for multiple OSs that are based on Unix, another operating system. Thanks to Linux being open source, variants of Linux come in all shapes and sizes, suited best for what the system is being used for. For example, Ubuntu and Debian are some of the more commonplace distributions of Linux because it is so extensible. You can run Ubuntu as a server, such as websites and web applications, or as a fully fledged desktop. For this series, we're going to be using Ubuntu. Note, Ubuntu server can run on systems with only 512 megabytes of RAM. Similar to how you have different version Windows 7, 8, and 10, there are many different versions or distributions of Linux. Okay. So Linux can seem harder to use than Windows, but it has many advantages, such as being lightweight. Okay, so you probably use Linux every day without realizing it. It is used in websites and web servers, car control systems, shop checkout systems, and important infrastructure like traffic lights and sensors. Linux is a general name for many different versions called distributions because it is open source, meaning anyone can modify it. Common Linux distributions include Ubuntu and Debian. So this course we will use the Ubuntu. Some Linux versions can run on very low system resources, even with only 512 megabytes of RAM. So just like Windows has versions 7, 8, and 10, Linux also has many distributions designed for different purposes. And we have a question. Research. What year was the first release of a Linux operating system? So we can use a Google here, and we can uh, search this one on the internet. So let's copy that one. And let's see. Okay, so what year was the first release of a Linux operating system? The very first version, Linux 0.01, was released on September 7, 1991. Initial release. So year is 1991. It's like the answer here. All right. Next, task 3, interacting with your first Linux machine in browser. This room has a Ubuntu Linux machine that you can interact with all within your browser whilst following along with this room's material. However, to get started, simply press the green Start Machine button below. Okay, Start Machine. Once deployed, a card will appear at the top of the room. Card will appear. Okay, so this one, target machine information. This contains all of the information for the machine deployed in the room, including the IP address. Okay, the IP address. It's still counting. And expiry timer. Okay, expiry timer expires 1 hour, 59 minutes, and 30 seconds. Okay, along with buttons to manage the machine. Okay, we have add 1 hour and terminate. Remember to terminate a machine once you are done with the room. More information on this can be found in the tutorial room. For now, press Start Machine. Okay, we already press it, where you will be able to interact with your own Linux machine within your browser whilst following along with this room. Okay, so here, start the machine. This is the Linux machine. Okay. Answer the questions below. I've deployed my first Linux machine. No answer needed. Okay. So this task gives us access to a Ubuntu Linux machine that runs directly inside my web browser. To begin, I click the green Start Machine button. And after the machine starts, I will see a panel at the top of the page showing the IP address of the machine. Okay, so right here. This is the IP address of the machine. Okay, the time remaining before it shuts down. Okay, and buttons to manage the machine. Add 1 hour and terminate. So when I'm done using it, remember to terminate the machine so I don't leave it running. I will use this in-browser Linux machine to follow the rest of the lessons and practice commands, so I don't need to turn this one off. Okay. Now, that's task 3. Task 4, running your first few commands. As we previously discussed, a large selling point of using OSs, such as Ubuntu, is how lightweight they can be. This, of course, doesn't come without its disadvantages, where, for example, often there is no GUI or graphical user interface. Yeah, it's like only black. Or what is also known as a desktop environment that we can use to interact with the machine unless it has been installed. Okay. A large part of interacting with these systems is using the terminal. Okay, this is terminal. Okay. The terminal is purely text-based. This is what it says. This is what a terminal looks like. Okay. Right. So, however, if we break down some of the commands after some time, you quickly become familiar with using the terminal. We need to be able to do basic functions like navigate to files, output their contents, and make files. The commands to do so are self-explanatory once you know what they are, of course. Let's get started with two of the first commands, which I have broken down in the table below. Okay. Command, echo, and who am I? So description, output any text that we provide. Who am I? Find out what user we're currently logged in as. Okay, see the snippets below for an example of each command being used. Using echo, echo, hello, hello, echo, hello friend, hello friend. As shown in the terminal above, if we want to echo a single word, we don't need to use double quotes. No double quotes. However, the string should be enclosed with double quotes if one or more spaces are present. Okay, right here. There's a space. Okay. For example, echo, hello friend. So we need to do double quotes. Okay. Who am I can be used to find the username we are logged in as. So using who am I to find out the username of who we're logged in as. Who am I? Okay. Try this on your Linux machine now. Okay. So many Linux systems do not have a graphical user interface or GUI, so we use the terminal to type commands. The terminal is text-based and may look unfamiliar at first, but it becomes easier with practice. So here I need the terminal to do basic tasks like moving through folders, viewing files, and creating files. There are two beginner commands that are introduced, which are echo and who am I. Echo, it shows or prints the text on the screen. And who am I, it shows the username of the current user. Okay, so let's try. So we have two questions here. If we wanted to output the text Tryhackme, what would our command be? Okay, so Tryhackme doesn't have space, it's just only single word. So we're gonna use echo and then Tryhackme. It's echoes, Tryhackme. So it's our answer. What is the username of who you're logged in as on your deployed Linux machine? So we're gonna use who am I for that one. Okay, Tryhackme. So next is task 5, interacting with the file system. So far, we've only covered the echo and who am I commands. Not all that useful when you consider things that we need to do, including navigating this file system. Read and write to it as well. In this task, we're going to be learning the commands so that we can do just that. Just like the previous task, I'll display the commands in the table in the next heading and show examples of these commands being used. Interacting with the file system. As I previously stated, being able to navigate at the machine that you are logged into without relying on a desktop environment is pretty important. After all, what's the point of logging in if we can't go anywhere? Command, ls, full name, listing, cd, change directory, cat, concatenate, pwd, print working directory. So listing files in our current directory. Before we can do anything such as finding out the contents of any files or folders, we need to know what exists in the first place. This can be done using ls command, short for listing. Using ls to list the contents of the current directory. So this is the current directory, ls, and inside, the contents inside the current directory has important files, my documents, and notes, and pictures. Okay. So in the screenshot above, we can see there are the following directories and folders: important files, my documents, notes, and pictures. So great, you can probably take a guess as to what to expect a folder to contain given by its name. Pro tip, you can list the contents of a directory without having to navigate to it by using ls and the name of the directory. For example, ls pictures, okay? ls pictures, ls notes, ls my documents, ls my important files. Maybe we should try that. ls, current directory. What's inside the current directory? We have access.log, folder 1, folder 2, folder 3, folder 4. And it says you can list the contents of a directory without having to navigate by using ls and the name. Of the directory, name of the directory. List the contents of a directory. Let's try to check. What if we ls access.log? What will happen? Okay, it gives us access.log. Right? ls folder 1. Nothing. ls folder 2. Nothing. ls folder 3. Nothing. ls folder 4. Note.txt. There is something inside folder 4. Okay. Next, change our current directory or CD. Now that we know what folders exist, okay, right here, we need to use the cd command, short for change directory, to change to that directory. Say, if I wanted to open the pictures directory, I'd do cd pictures, where again, we want to find out the contents of this pictures directory. And to do so, we'd use ls again. Okay, so here we have the current directory and the pictures. Let's go cd pictures. Okay, let's try that. cd folder 1. Okay, so now we are inside the folder 1. Okay, and then it says ls again. If we try to ls inside the folder 1, there's nothing. So next, outputting the contents of a file. However, folder 1 doesn't have anything, but the folder 4 has. So here, how can we go back to our directory, the main directory? So we don't want to stay in folder 1. We want to go back to our directory only, this one. So how can we do that? We will do that by using a cd and then dot dot. Okay, there you go. It means try like, hey, take me back to the previous one. Okay. Next, let's try cd folder 4 because that's the one that has a file. Okay, we are inside folder 4 now. We'll try to ls that. Okay, so we have the note.txt. Just like here, ls, we have something inside the pictures. So our folder 4 has got note.txt. There's only one. Okay, next, outputting the contents of a file or cat. Whilst knowing about the existence of files is great, it's not all that useful unless we're able to view the contents of them. So right here, we need to view the contents. We will come on to discuss some of the tools available to us that allows us to transfer files from one machine to another in a later room. But for now, we're going to talk about simply seeing the contents of text files using a command called cat. Cat is short for concatenating, and it's a fantastic way for us to output the contents of files, not just text files. In the screenshot below, you can see how I have combined the use of ls to list the files within a directory called documents. So using ls to list the contents of the current directory. Okay, so documents, ls to do text, documents, cat to do text. Here's something important for me to do later. Okay. So it teaches us to ls something that has text. It's like this, the note.txt. So we are in now folder 4. We ls it earlier, ls. So we have this note.txt, similar to do.txt. So we are going to use the cat. And then note.txt. That's good. Okay, so we have something inside that note.txt. Inside the note.txt is the word hello world. Okay, similar to this one. Here's something important. Later. Good. So we have applied some knowledge from earlier in this task to do the following. Use ls to let us know what files are available in the documents folder of this machine. So for us, we try to use ls to check what's inside the folder 1, 2, 3, and folder 4. Next, we have then used cat to do the text or txt to concatenate output the contents of this to do text file. Where the contents are, here's something important for me to do later. So similar to what we did, we have used cat to cat the note.txt. And of course, we saw the content, which is hello world. So pro tip, you can use cat to output the contents of a file within directories without having to navigate to it by using cat and the name of the directory. So cat, home, Ubuntu, documents to do the text. Okay, so here we're going to, if you wanted to do this, maybe we can try it. cd. Let's just try it. Okay, nothing will happen. Okay, let's say, let's use pwd first. Okay, we have here home/Tryhackme. Okay, and then folder 4. All right, so let's try cat home Tryhackme. Okay, slash folder 4 slash note.txt. Hello world. Very good. So sometimes things like usernames, passwords, flags, or configuration settings are stored within files where cat can be used to retrieve this. Finding out the full path to our current working directory, which is the pwd. Oh, that's what I did earlier. Okay. So you will notice as you progress through navigating your Linux machine, the name of the directory that you are currently working in will be listed in your terminal. It's easy to lose track of where we are on the file system exactly, which is why I want to introduce PWD, which stands for Print Working Directory. Using the example machine from before, we are currently in the Documents folder. But where is this exactly on the Linux machine's file system? We can find this out using this pwd command, like within the screenshot below. So using pwd to list the full path of the current working directory. So Tryhackme at Linux 1 documents, okay, pwd, home Ubuntu documents. So just like what we did earlier, okay, pwd, home, Tryhackme. So let's break this down. We already know where we're in documents thanks to our terminal, but at this point in time, we have no idea where documents is stored so that we can get back to it easily in the future. So I have to use the pwd or the print working directory command to find the full file path of this documents folder. We're helpfully told by Linux that this documents directory is stored at home Ubuntu documents on the machine, which is great to know. Now, in the future, if we find ourselves in a different location, we can just use cd /home/ubuntu/documents to change our working directory to this documents directory. Okay, that's a long one. So this task teaches me how to navigate and read files in Linux using the terminal. I learned four important commands: ls, cd, cat, and pwd. ls shows the files and folders in the current location. The cd, it moves me into a different folder or directory. Cat displays the contents of a file, and the pwd shows the full path of my current location. So for the ls, list files and folders, it shows what exists in the current directory. So I can also list what's inside another folder without going into it by, of course, using ls and then the name, let's say folder 4. All right, so let's have a look at the questions. Answer the questions below. On the Linux machine that you deploy, how many folders are there? So we see the folder right here. We have 4. Which directory contains a file? That's folder 4 directory. Now, what is the contents of this file? We saw the content, hello world. Okay. Using the cd command to navigate to this file and find out the new current working directory. What is the path? So again, it says it wants us to cd to go to the use the cd command to navigate to this file, which is the folder 4. Okay. But let's go there, cd folder 4. Okay. Now we have navigated to folder 4. Next, we need to find out the new current working directory. That's what it needs. So we're going to use pwd. So here we have /home/tryhackme/folder 4. Okay, so that's the end of task 5. Next, task 6, searching for files. Although it doesn't seem like it so far, one of the redeeming features of Linux is truly how efficient you can be with it. With that said, you can only be as efficient as you are familiar with it, of course. As you interact with OSs, such as Ubuntu over time, essential commands like those we've already covered will start to become a muscle memory. One fantastic way to show just how efficient you can be with systems like this is using a set of commands to quickly search for files across the entire system that our user has access to. No need to consistently use cd and ls to find out what is where. Instead, we can use commands such as find to automate things like this for us. This is where Linux starts to become a bit more intimidating to approach, but we'll break this down and ease you into it. Using find. The find command is fantastic in the sense that it can be used both very simple or rather complex depending on what it is you want to do exactly. However, let's stick to the fundamentals first. Take the snippet below, we can see a list of directories available to us. So we have desktop directory, documents directory, pictures directory, and folder 1 directory. Now, of course, directories can contain even more directories within themselves. Becomes a headache when we're having to look through every single one just to try and look for specific files. We can use find to do just this for us. Let's start simple and assume that we already know the name of the file we're looking for. Okay, assume that we already know the file we're looking for, but can't remember where it is exactly. In this case, we're looking for passwords.txt. If we remember the file name, we can simply use find-name passwords.txt, where the command will look through every folder in our current directory for that specific file, like so. So first, let's try to cd again to our main directory. Okay, using find to find a file with the name of passwords.txt. So find name passwords.txt. Okay, so this passwords.txt will change that to note.txt. All right, so let's try. Find dash name. The name is note.txt. Okay, so it says we have the dot slash folder 4 slash note.txt. Okay, so find has managed to find the file. It turns out it is located in folder 1 slash passwords.txt. But let's say that we don't know the name of the file or want to search for every file that has an extension such as .txt. Find let us do that too. We can simply use what's known as a wildcard or asterisk to search for anything that has .txt at the end. In our case, we want to find every .txt file that's inside our current directory. We will construct a command such as find-name asterisk.txt. Okay, find-name. We don't know exactly the name, so we're going to use asterisk.txt. Okay, so again, it finds out there's only one note.txt, which is the note. So here, where find has been able to find every .txt file and has been given us the location of each one. So here, it find the name *txt. They've got passwords.txt. They've got to-do.txt in the example. So find has managed to find passwords.txt located within folder 1, and then to-do.txt located inside the documents. Next, using grep. Another great utility that is a great one to learn about is the use of grep. The grep command allows us to search the contents of files for specific values that we are looking for. Take, for example, the access log of a web server. In this case, the access.log. Okay, so we have the access.log earlier right here. All right. Okay, so in this case, the access.log of a web server has 244 entries. Okay, 244 access.log. Okay. So using WC to count the number of entries. So here we use the WC command is to count the number of entries inside the access log. So WC is word count. So word count. For the word count, I want you to count the number of entries inside the access log. Okay. -L. Okay. L is like the number lines numbers, I think. So using a command like cat isn't going to cut it too well here. Let's say, for example, if we wanted to search this log file to see the things that a certain user or IP address visited, looking through 244 entries isn't all that efficient considering we want to find a specific value. Okay. We can use grep to search the entire contents of this file for any entries of the value that we are searching for. So going with the example of a web server's access log, we want to see everything that the IP address 81.143.211.90 has visited. Note that this is just fictional. So using grep to find any entries with the IP address in access.log. Grep, find me the IP address this very specific IP address inside the access.log. And it gives you. So here's the IP address. Okay, it has the date and the time. And we also have a get right here, the get request, HTTP 1.1.200.417, Mozilla 5.0, Linux Android 7.0, Moto G4. Okay, so grep has searched through this file and has shown us any entries of what were provided and that is contained within this log file for the IP. So that is the task sys. So this task teaches me how to search for files and search inside files without manually opening folders one by one. I learned two helpful commands here. One is find, which searches the four files and folders by name or pattern, and grep searches inside the files for very specific text. So find searches, search for files and folders. Use this command to search the file system for files by any or by name or pattern, where the file, or if we wanted to file the file with a specific name, we have to use the command find dash name and then the name of the file, like let's say the note.txt. And next, if we don't know the exact name of the txt file, we can use a wildcard, which is the asterisk called wildcard, right? So find dash name and then the wildcard or the asterisk dot txt. So that kind of symbol means, the asterisk symbol or the wildcard symbol means match anything. So wildcard.txt means any file that ends with .txt. Now the grep, so use grep when you want to find specific words or specific numbers or specific IP addresses or specific email addresses or etc. inside a file. So just like from the example earlier, like write the word grep and then a very specific IP address, which is the 81.143.211.90 inside the access.log. So this shows every line in access.log that contains this IP address. Now, for the extra command that is shown, like the wc-l. So in this part, so when we say wc-l, it's like count lines, try count lines in the file, wc-l. So this is where we can use wc-l access.log. So count lines in the file, which is the access.log. So I think these are extremely useful for cybersecurity, especially when analyzing the logs and hunting for important information. So let's try to answer the questions below. Use grep on access.log to find the flag that has a prefix of thm. Okay, so it gives us a very specific word, thm. So let's use grep, and then thm. Let's try to use the double quotes, thm. Okay, so grep, thm, and then, of course, inside the access.log. All right, so here we have thm access. And the second one, and I still haven't found what I'm looking for. Okay, we don't need anything from this. Next, an introduction to shell operators. Linux operators are a fantastic way to power up your knowledge of working with Linux. There are a few important operators that are worth noting. We'll cover the basics and break them down accordingly to bite-sized chunks. At an overview, I'm going to be showcasing the following operators: symbol or operator, description. So I think this is called, sometimes we call it and sign, but I think it's called ampersand. So ampersand, this operator allows you to run commands in the background of your terminal. Double ampersand, this operator allows you to combine multiple commands together in one line of your terminal. Okay. So the single ampersand runs a command in the background so I can do other things while it runs. Okay, so the double ampersand, it runs multiple commands in order, but the next command only runs if the first succeeds. Okay, so this one, single right arrow. This operator is a redirector, meaning that we can take the output from a command, such as using cat to output a file and direct elsewhere. So this single right arrow redirects the output of a command into a file, overwriting the file if it exists. Next is the double arrow sign. This operator does the same function of the single right arrow operator, but appends the output rather than replacing, meaning nothing is overwritten. So this double right arrow redirects the output of a command into a file, appending to it without overwriting. Let's cover this in a bit more detail. Okay, the single ampersand. This operator allows us to execute commands in the background. For example, let's say we want to copy a large file. This will obviously take quite a long time and will leave us unable to do anything else until the file successfully copies. The ampersand or the single ampersand operator or shell operator allows us to execute a command and have it run in the background, such as this file copy, allowing us to do other things. Okay. So this runs a long command in the background, letting you continue typing other commands. Next, the double ampersand. This shell operator is a bit misleading in the sense of how familiar it is to its partner, single ampersand. Unlike the single ampersand operator, we can use the double ampersand to make a list of commands to run. For example, command 1 and command 2. However, it's worth noting that command 2 will only run if command 1 was successful. Okay, so here, command 2 will only run if command 1 finishes successfully. Next, single right arrow operator. This operator is what is known as an output redirector. What this essentially means is that we take the output from a command we run and send that output to somewhere else. A great example of this is redirecting the output of the echo command that we learned in task 4. Of course, running something such as echo howdy will return howdy back to our terminal. That isn't super useful. What we can do instead is redirect howdy to something such as a new file. Okay, so redirect the output. All right. Let's say we wanted to create a file named welcome. With the message, hey, we can run echo hey, and then the right arrow, welcome, where we want the file created with the contents hey, like so. So using the right arrow operator, echo hey, dot right arrow, welcome. Okay, let's try that one. Echo hey, right arrow, welcome. Next, cat welcome. Cat welcome. Hey. So because welcome is a file, we have to cat like or a folder. So just like earlier, the folder 4. So inside the welcome, it has the word hey. That's why we use the word cat or command cat, I would say. Now, if the file welcome already exists, the contents will be overwritten. Okay. Let's say it says if the file welcome already exists, the contents inside the file will be overwritten. Okay, so let's say echo yo, right? Welcome, right? And now we're going to cat welcome. It will changes the hey to yo. It will be overwritten because welcome is already exist. And then, inside the welcome, it has the word hey. So now you cannot write another folder that name welcome again because it will change what's inside that previous welcome folder. Okay, next, operator double right arrow. This operator is also an output redirector, like in the previous operator, which is the single arrow we discussed. However, what makes this operator different is that rather than overwriting any contents within a file, for example, it instead just puts the output at the end. Okay, let's try. Okay, so let's try echo again. Echo. Okay. Okay. Welcome. Right. Sorry, I forgot. Hey, echo. Hey, welcome. Okay. Echo at welcome. Make sure that we're in hey. Okay. Now let's try. So following on with our previous example where we have the file welcome that has the contents of hey, if we're to use echo to add hello to the file using the single operator, the file will now only have hello and not hey, right? Just like earlier. We change it to, now we try to make another folder that has the same word welcome, but it overwrites in the word inside that folder welcome. It changes to yo, no more hey. Now, the double right arrow operator allows us to append the output to the bottom of the file rather than replacing the contents like so. Okay, let's try. So we have the hey inside welcome, and if we're going to say echo, hello, and then we are going to use this double right arrow inside the same folder, welcome. And then if we are going to cat that folder welcome, we have hey and hello, which means that it's not going to overwrite what's inside that welcome folder anymore. It will add a new word. So unlike the single right arrow, which overwrites any word that's inside that welcome folder, this double right arrow will add the new word. Now, here, if we wanted to run a command in the background, what operator would we want to use? Okay, so of course, we want to use the single ampersand because, again, this runs a command in the background. Okay, it lets me or lets us continue typing other commands. If we wanted to replace the contents of a file named passwords with the word password123, what would my command be? So again, just like earlier, we have to use the single right arrow because we wanted to replace the contents, the word inside the file. The file name password, and then the word that we wanted to use to replace the word is password123. So we have to use echo password123 single right arrow, then passwords. Now, if we wanted to add Tryhackme to this file named passwords, okay, so this file named password just like the welcome, but also keep passwords123. Again, we want to keep the password123 along with the word Tryhackme. What would my command be? So again, echo Tryhackme, double right arrow, and then the passwords. Now, use the deployed Linux machine to put this into practice. Okay, so we already practiced that one. Task 8, conclusions and summaries. Okay, so we are task 8. Okay, I think this task is just a review of everything learned in the Linux fundamentals from so far. Key points covered, learned why Linux is widely used in the real world, so started interacting with the Linux machine in my browser. Okay, ran basic commands like echo, who am I, ls, cd, cat, and pwd. Learn how to navigate the file system and search for files and text using find and grep. Learn about shell operators, the single ampersand, double ampersand, single right arrow, and double right arrow operators to make commands more efficient. These are the essential skills that we will use frequently whenever we work with Linux. And we don't have any questions here. Just click that part. Task 9. Okay, so this is a link to part 2 of the Linux Fundamentals series. So we should go to the Tryhackme room to continue learning more advanced Linux topics. And I'll see you in part 2.